Okay, so last time I covered a lot of ways in which biodiversity is directly beneficial to humans. Um, I guess not just in the quality of life, it's nice to have pretty forests and mountains and flowers sense, but in direct products that are immediate economic benefit to a lot of people, medications, food sources, sources of fuel, ideas for consumer products, all kinds of things. Biodiversity is economically beneficial. But I focused a lot on single species that have been useful. And it's important to preserve those, but it's not efficient because there's no species of any living thing that's truly isolated. Every living thing, from you to Escherichia coli bacteria and everything in between, depends on the ecosystem that it's a part of, because that ecosystem includes food sources, symbionts, even the predators may actually be important in maintaining a population. That's the chick of a California condor, one of the largest flying birds. And condors were almost wiped out in the 1970s. The very last of them were trapped and brought into refuges and raised by human conservationists. That baby bird is not being fed by its mommy, it's being fed by a hand puppet. That's how much effort it took to save the condor. But if you really want to save species permanently, like this California condor in flight, you can't just save the one species in zoos or what have you. You've got to protect the ecosystems that California condors are a part of. You've got to protect the whole thing. One thing you have to keep in mind when you're preserving ecosystems is the concept of a keystone species. Keystone species are species whose presence have a very large effect on the total ecosystem and a very large effect on overall species diversity out of proportion to their numbers. Sometimes a keystone species might also be an apex predator, right? That's the predator at the top of the food web at the highest trophic level that is not eaten by any other predator, but it doesn't have to be. A keystone species does not have to be an apex predator. It may not even be a predator at all. And the reference is to the keystone of an arch. That's the keystone of this arch, and that happens to be on the UCA campus because we've got a lot of arches here. And the keystone is this wedge-shaped stone at the very highest point of an arch. And you can actually make arches stand up without mortar, but if you pull the keystone out, the entire thing collapses. And that's the idea of a keystone species. If you pull it out, the entire ecosystem may collapse, or certainly may transform into something very different from what it looked like when you started. And here's a pretty well-known example. This is a prairie dog. It's not really a dog. It's a rodent, genus Cynomys. And prairie dogs build, or they used to build, very large communal burrows. You'd have in hundreds or maybe thousands of individual prairie dogs living in these burrow networks on the North American prairie, in the grasslands. Most of these grasslands have been turned into farmland now, and prairie dogs are not extinct, but there's not nearly as many of them as there used to be. Although at one time there was a colony of them in the Little Rock Zoo, so you can go see them if you want to, I think. So what's so great about prairie dogs? They're a great example of a keystone species. Why? Well, one reason is they're food for predators like black-footed ferrets, foxes, badgers, and hawks. So they're food for predator species. But there's more to it than that. Their burrowing activity increases the soil's ability to retain water. If a soil has a lot of burrows dug in it, then when the rains come, water soaks into the burrows and soaks into the soil, and it soaks in more efficiently than if there weren't any burrows. It doesn't just flow over the surface. So that burrowing activity allows more plants to grow. The fact that there are more plants there allows for more insects and more grazing animals, more deer and pronghorn and buffalo or bison, things like that. The burrowing also attracts insects, and the insects get fed on by insect-eating birds, like scissor-tailed flycatchers and things like that. And then prairie dog old burrows that the prairie dogs have abandoned make a habitat for burrowing owls, rabbits, certain lizards, foxes, things like that. So if you take prairie dogs out of the equation by trapping them, shooting them, or plowing the land and stopping them from growing there, you affect not just the prairie dogs, you affect a very large number of other prairie species. Take the prairie dogs out and the entire ecosystem collapses into something completely different from what it was. That's a keystone species. And even if prairie dogs do not directly benefit humanity, their presence might be important for something that does. So that's what I mean when I say it's not efficient to save species by species. You've got to preserve the entire ecosystem. So let me talk about the value of ecosystems. Here's one. This is a beautiful Ozark mountain scene with lovely trees and shrubs. And you can't see them in this picture, but running around among the beautiful trees and shrubs, there are adorable furry animals and no doubt in season, magnificent flowers. So which ecosystem would you rather preserve? Which one should be made maybe a national park or something like that? This beautiful Ozark mountain scene, or this slimy, foul-smelling, mosquito-infested coastal salt marsh in South Louisiana? Which one is more worthy of preservation? This beautiful Ozark mountain scene with magnificent fall foliage, or this mucky, slimy marsh that's loaded with mosquitoes? There's no real answer to this. This is more to get people thinking than anything else. I mean, I know where you'd probably rather build your house or, have deer camp or something like that. Maybe those Louisiana salt marshes are not as beautiful as the Ozarks, but Louisiana wetlands and the whole ecosystem and all the communities in it, collectively, they provide about 1/6 of the US seafood catch, and seafood in the US, that's $1 billion industry. People also take furs and hunt ducks and go boating and go fishing in the Louisiana wetlands. What's more, and probably more important, they serve as a barrier against hurricane damage. When hurricanes come in off the Gulf of Mexico, the coast gets hit with winds up to, in some cases, 150 miles an hour, and you can get storm surges, these huge waves many feet high. Now, if that hits a beach house, that beach house is destroyed. If it hits wetlands, the wetlands may get damaged, but the wetlands can repair themselves. The wetlands will grow back if you let them. And the wetlands will absorb that wind and storm surge damage. The value of all US wetlands for storm protection has been estimated at $23.2 billion a year. That's $23.2 billion that you save by not having to rebuild houses that are set back from the coast and protected by wetlands. That's $23.2 billion worth of real estate you don't have to rebuild. That's $23.2 billion of insurance that you don't have to pay out. And one of the reasons why Hurricane Katrina back in 2005 was so bad is that New Orleans used to have, 50 miles of mostly wetlands between it and the open ocean, the open waters of the Gulf of Mexico. For several reasons, some natural and some not, a lot of that wetlands is not there anymore. You can now see open water from the top of the skyscrapers in New Orleans. And one of the contributing factors to why Katrina was so bad is that New Orleans has lost most of the protection that it used to have from hurricane-driven storm surge waves coming close. Wetlands, by the way, are also purifiers of water. If you dump sewage into a wetland, well, the decomposers will break that down, and the plants, the primary producers, will ultimately absorb all that nitrogen and phosphorus that you're dumping in. And what comes out of the wetlands is much cleaner water. These wetlands that you see were actually built by a small town near Savannah called Richmond Hill, Georgia. And the wetlands can treat over 1 million gallons of wastewater a day. All of the, shredded food from garbage disposals and all of the town's collective urine and feces and stormwater and all that passes into the wetlands. The ecosystem that's already there, the decomposers break down the waste, the plants absorb some of the waste, and they treat 1 million gallons of wastewater per day at a cost of about 10% of a traditional sewage treatment plant. And that's why it's potentially alarming that the US has lost so much of its wetlands since 1900s. Louisiana's lost in the past 80 years, that state's lost 2,000 square miles. On the left is a highway sign with the official shape of the state of Louisiana. On the right is what that highway sign would look like if you showed the real amount of wetlands lost. Louisiana loses wetlands at the rate of about 1 football field per hour. And that's potentially concerning, not just because of the loss of the plants and animals that live there, but because the entire ecosystem provides services like water purification and storm protection, and we don't have to pay anything for those. Okay, maybe you're not really interested in wetlands. Here's a coral reef. Reefs are critically endangered right now. Part of this is because of climate change, increased temperatures in the oceans, increased acidity in the oceans, and in part because of human activity, like farming practices causing soil runoff and making the water less clear. Or in some cases, things like dynamite fishing or certain types of mining. All of these are potential threats to coral reefs. Well, the World Wildlife Fund worked out in 2003 that if you could preserve all of the world's coral reefs as they were, they would generate close to $30 billion in economic activity. Over $5 billion worth of seafood comes out of coral reefs. About $9 billion in protecting coast from storm damage, similar to wetlands. When a hurricane hits a coral reef, the corals might break, but if it's healthy, they'll grow back And what they'll do is absorb a lot of the energy of damaging waves and keep them from hitting the dry land where people are living. So that's $9 billion that you don't have to pay in rebuilding real estate or resettling people, or paying out insurance claims, things like that. That's $9 billion you save. Almost $10 billion in opportunities for recreation and tourism, because a lot of people like to go skin diving or scuba diving on coral reefs, and they'll travel a long way to get there. And remember that sea slug I talked about? There's a number of coral reef critters that contain chemicals that are of interest or are actively being tested as drugs. So they estimated over 5 billion a year is the value of future drugs and other products that could be isolated from critters on a coral reef. So if we could save all of the world's coral reefs, that's nearly $30 billion added to the global economy. Probably the most single important ecosystem is actually soil. It's not well understood, but soil is so diverse, it's been called the poor man's rainforest. You can't really make soil artificially. Soil starts as eroded rock. But what makes soil different from the kind of eroded dust that you'd find on the moon is the actions of bacteria and archaea and fungi and plants and protists. There's lots of protists in soil. When I was a senior as an undergraduate, I did an honors research project on protists in soil. They're really cool. And you've got earthworms and snails and slugs and mites and spiders and leeches and insects and springtails and pseudoscorpions. Tons of critters living in soil and leaf litter, and they're ultimately the ones that maintain a soil's fertility. We can't magically make soil. It's ultimately dependent on that entire ecosystem going on. Much of it you can't even see with the naked eye, but there's a huge complicated ecosystem right under your feet. And all of your food that isn't fished ultimately depends on that soil. So back in 1997, a guy named Dr. Robert Costanza tried to put a price tag on the biosphere. There are some uncertainties in this, so you shouldn't take these numbers as rigid, but he tried to estimate the total economic value of everything that biology provides to humanity. That's everything from medicinal products to food sources like seafood or plants, to creation of soil, purification of air and water, protection from storm damage, the very oxygen that you breathe. What's the economic value of everything that the living world, the biosphere, provides? Well, in 1997, the total value of the world economy was $18 trillion. That's the total cash value of everything that humans produce and buy and sell, and all of the services that humans do for each other and get paid for each other. $18 trillion in 97. His estimated value of all of the goods and services provided for free by the biosphere, by the living world, was at least $33 trillion. It might be higher. He said it might be 56 trillion. It could even be more than that. But the total economic value of everything that the living world does for us is somewhere between 2 to 3 times as great as the value of all of the goods and services that humans provide for each other. Okay, and I still don't understand why the School of Business got the bigger building. because biology's value is 2 to 3 times the value of all that stuff they study in the College of Business. Costanza followed it up with another study in 2002. If you could invest $45 billion, which is about what Elon Musk just paid for bleeping Twitter, if he'd invested that in preserving as much wilderness and ocean as is still possible to preserve, he'd get 100 to 1 return on his investment, between $4.4 and $5.2 trillion worth of benefits like clean air, clean water, food supplies, new consumer products, new drugs, all of the things that we've talked about. He'd get 100 to 1 return on investment. Which raises the question, why did Elon Musk spend all that money on bleeping Twitter and not spend it on this 100 to 1 investment in preserving as much biodiversity as possible? Now, some of our oligarchs have done that, like Ted Turner owns ridiculous amounts of the American West, and I think he really does try to preserve it as well as he can. But why isn't Elon doing the same thing? Here's the problem. Okay, right. We seem to be back. I'm sorry I faded out there for a second. Let me see, are we still doing the screen share thing? All right, I think we are. I take it everybody can see that. So why Elon Musk buying something like Twitter and not preserving every last coral reef that he can? The problem is that a lot of the benefits that we get from biodiversity are public goods. That means that they benefit everyone regardless of whether you pay for them or not. Clean air, you don't have to pay anything for air. I'm sure they're working on a way to make you do that, but right now you don't have to pay for the air that you breathe. And if that air is clean, you benefit regardless of whether you've done anything to deserve that clean air. That's a public good. Private goods, the opposite, only benefit the people that buy it. The Happy Meal that you bought for lunch yesterday, or whatever it was, only benefited you, or maybe you shared it, but it only benefited the people that ate it. Happy Meals only benefit the people that buy them.
We can't see the slides.
You can't? Okay,
Yeah.
hang on, let me try to fix that. Okay, sorry, checking chat, just making sure that's still running. Okay, let me go to screen share, basic, share slides. Okay. All right, sorry about that. Okay, so think about this. If you clear cut a forest to make it into truffula trees or something like that, you get to keep the money from selling the timber or what have you. Now, if you cut all the trees in a forest, you lose soil because it starts washing away, it starts eroding. You lose the clean air and the purified water that plants can produce for you. You lose all of the species that were living in and among the trees. You know, you lose the barbaloots and the singing fish and everything. But that's shared among everybody in the neighborhood. If you own a chemical plant that's polluting the air and polluting the water, you get the money from the plant, you get the money from your activities, but the bad air and the bad water are shared by everybody that has to live in the neighborhood. You know, they're not shared by you. You can afford to live somewhere that's nice. And a cost like that, which is paid whether or not people choose to pay them, are called externalities. So if you live next to a chemical plant, you probably don't want to breathe toxic air, but you're still going to, and it's a cost in that it makes you less healthy, it makes you more sick, it cuts down the number of things you can do. That's called a negative externality. On the other hand, if the factory cleans up its act and puts out good air, that's a positive externality because it benefits you whether or not you paid for it. So when the cost of using a resource is shared, but the benefit goes to individual people, those individuals are going to maximize using that resource, even if the end result is destruction of the resource. Villages back in the old days used to have what was called the commons. And commons was grassland that wasn't owned by any one person. It was owned by the entire village, and everybody in the village could keep their sheep on the grassland. Here's the problem. Let's say everybody has 10 sheep on this commons, and they're all healthy, they're all grazing, and the people that own them can sell the wool and make money. One guy says, hey, I'd make more money if I had 11 sheep. So he puts 11 sheep where he used to have 10. Now there's a tiny bit less grass for everybody else, but there's direct economic benefit for the one guy. The one guy now has a whole extra sheep and all of the wool that sheep produces. The negative externality is spread out among everybody. Everybody's sheep have just a little bit less grass, but it's not a big deal. But then the guy's neighbor said, hey, he's got 11 sheep. I'm going to do that too. So the next guy gets the full benefit of having one sheep. And then the negative externality is the fact that there's a little bit less grass. So everybody is harmed in a very small way. And then a third person says, hey, I'm going to get 11 sheep. And a fourth guy says, oh yeah, I'm going to get 12. And then the fifth guy says, hey, what if I get 13? And so everybody is trying to maximize use of the commons resource because they're taking the profit from their own sheep and spreading out the negative effects, spreading out those negative externalities. The problem is the ultimate result is that the commons is completely destroyed. There's no grass left. All of the soil washes away and there's no benefit for anybody. That's what we call the tragedy of the commons. The fact that when individuals benefit, but the cost can be shared, individuals will maximize their benefit even if the end result is the resource getting destroyed. And I'm going to show you a real world example of this. That is Gadus morhua, the Atlantic codfish. Used to be incredibly abundant in the North Atlantic. Fairly easy to catch, easy to dry or salt if you couldn't eat it fresh. And for hundreds of years, it was a cheap, nutritious source of protein. You know, this is traditionally what English fish and chip shops used to serve. What they used to serve a lot of in, New England, in Massachusetts and Maine and places like that. A lot of cod was fished. People made a living as cod fishermen. They depended on the cod. Well, what happened was that cod fishermen I'll focus on Canada, did exactly what economics would say that they should do. They fished for cod, they sold their catch, and they took some of their profit and invested in more boats, or they might invest in larger boats. And then as the technology got better and better, they started investing in refrigerated boats, which meant that you could catch more fish because you could stay away from land for longer and keep your catch fresh. And then after World War II, when the technology came along, they started investing their profits in things like sonar devices that would find the fish for them. In 1505, there were an estimated total of 7 million tons of Atlantic cod. In 1850, fishermen were catching about 100,000 tons each year. That number went up and up and up and up every year. In the 1950s, it really took off because of the use of sonar. And in about 1970, they were catching 800,000 tons of cod each year. And that was when the population started crashing. And it collapsed. And in 1992, there were so few codfish that the government of Canada shut the fishery down. There just weren't any codfish left. They have started making some recovery, and there's limited cod fishing that can be done now, but it may never be exactly the way it was. And there were whole decades when entire local economies, there were fishermen out of work who didn't know how to do anything else. It was really economically hard on all the communities that depended on that. And that's the tragedy of the commons. Fishermen were using this common resource. They did what economic theory suggests they ought to do and use their profits to maximize using the resource, catching more and more fish every year, investing in the technology that would let them do it. And it worked really well until the day it didn't work anymore and the fishery was destroyed. That's the tragedy in the commons. So what's threatening our biodiversity? Well, in the past 400 years, 27 of different biomes in the United States, we've lost 98% of or more. The little snippet of prairie that we preserve in the nature reserve, that's all that's left of what used to be hundreds of thousands of acres. That mixture of prairie and forest used to cover most of Arkansas. It's almost all gone. We've got one of the last little snippets of it that's left. And that's true of everything from our wetlands to old growth forests. Almost all of that's gone. We've converted in this country millions of acres into things like suburbs. Between 92 and 97, an area a bit less than half the size of Arkansas got turned into suburbs. It's happening in other countries as well. Brazil for a while was losing 20,000 square miles of Amazon rainforest every year, mostly for conversion into pasture land, land for raising cattle. One of the threats is introduced species that can outcompete natives. In Arkansas, Chinese privet and Japanese honeysuckle are notorious for outcompeting native species. Tropical rainforests may get logged, but mass suburb building does it too. California has lost possibly as much as 95% of unique ecosystem that it has, known as vernal pools. Shallow ponds that fill in the winter and dry up in the summer. There's a whole ecosystem of living things adapted to live there, and it's almost gone. Global climate change, huge effects that I don't think we fully understand what they're going to be yet. Growth of the population, growth of consumption. The bottom line is that we are losing species, possibly as many as 150 per day. It's hard to estimate the loss of something when you don't know what it is you're losing, which makes me want to quote the old song lyric cliche, you don't know what you got till it's gone. Extinctions always happened, but we're in the beginning of the 6th mass extinction that the Earth has ever seen. Most of the extinctions that are happening now, we can trace to human activity. Species are going extinct before we even discover them. And we don't really know what we're losing, but I want to impress on you that we're losing something incredible, something irreplaceable. And as Dr. Seuss said, unless someone like you gets off your ass and does something, starting with a hard look at your own lifestyle and the economy of the country that you live in, nothing is going to get better. It's not. But there might just be a little bit of time left to save some of the good stuff. And I'm simply going to leave you with that thought. I'm going to stop the recording now.